Okay, now that we've finished problem C, let's move on to E. Let's take a look at problem example E. Okay, so -3 cosine 2t plus 1. So a couple things we have here. We have the vertical shift up 1. We have the amplitude of 3. Amplitudes will always be positive. The negative tells us we have a direction change, so we need to determine the period. So with B being equal to 2, our period is going to be 2 pi over 2, which is just pi. So for our intervals, we multiply that by 1/4, we're going to end up with intervals of pi over 4. Oh. So 2 pi over 4 is just pi over 2, 3 pi over 4, and again that fourth one will be whatever the period is, in this case pi. So we got a lot going on here for this particular problem. One, we have a direction change and the stretch of 3. And I'll do those both at once. So instead of starting at 1, 0, I'm going to start at -3, 0. And then go back to the x-axis. Then I'm going to go to pi over 2, -3 in this case. Back to the x-axis at 3 pi over 4. And then at pi, I'm going to be at -3. That takes care of my stretch and direction change. Now, the vertical shift is up 1. I'm going to move all the points up 1 because I've already taken care of the period when I did my intervals. So I'll move all the points up 1. So here is our graph. So now our range becomes from -2 to 4. And notice again, if we were to chop the graph in half here, 1, 2, 3 from the top, 1, 2, 3 from the middle. Okay? And if we look at F, sine graph, we have a vertical shift of down 1. We have an amplitude of 2. Remember, amplitudes will always be positive. The period, B is 1/3. So we do the period being 2 pi divided by 1/3, which means that 2 pi times 3, and then with a period of 6 pi. So if we take 6 pi and we multiply that by 1/4, we're going to end up with 3 pi over 2. That's 6 pi reduces to 3 halves. So 3 pi over 2. Then we add another 3 pi over 2, that's going to end up being, let's say, 6 pi, so that would be 3 pi. Then we add another 3 pi over 2, that would be 9 pi over 2. And then again, that fourth mark is going to be 6 pi. So we're taking care of the period. So now, we get to do our graph, we do one piece at a time. Again, we have a stretch of 2. We start at the origin because that our stretch is not impacting where we start for our sine graphs. Right? When we're starting at the origin, instead of going to 1, 1 times 2 is 2. So it'll be 2. Back at the x-axis, instead of being at -1, we'll be at -2. And then back at the x-axis. So with the vertical shift of down 1, all the points will shift down 1. There. 2, I'm sorry, negative 3, rather, and then back to negative 1. So there lies our graph. Alright, take a moment and try G on your own. So pause the video and try G on your own and then come back and see what we want. In this particular case, we have an amplitude of 1/2. So anytime our amplitude is less than 1, then more than likely to make an effective graph, you need to change the intervals. So instead of each one being 1, now I'm going to say 1's here, 2's here, making each of these a half. So that'll be negative 1, and there will be negative 2. Okay? We have a vertical shift of up to, and again we need to determine the period. With E being 2, 2 pi over 2, which makes the period pi. So if we multiply by 1/4 or divide by 4, we're going to have pi over 4 pi 3 pi over 4 and I'm sorry, that would be pi over 2. And 3 pi over 4 and then pi. So, we've taken care of the period. We have a direction change and a compression of 1/2. So let's take care of that first and then we'll get into black. So instead of starting at 1, 0, we have that compression and the direction change. So we're going to be at negative 1/2, 0. X-axis, positive 1/2. X-axis, and back at negative 1/2. That takes care of the compression. Right? Now, we need to bump everything up to. So, 1, 2, 1, 2, 1, 2, 1, 2, and 1, 2. And there lies our graph. Okay, so if you want to complete it, notes for all of these examples, just check our platform, Google Classroom or Blackboard. Let's talk about the phase shift. That is our horizontal shift. So we're looking at left to right. So if you see minus, you're going to the right. Plus, you're going to the left. Right? Plus left, minus right. So in the first example here, we have the sign of x minus the half. So remember, regular sign, we have pi over 2 as our intervals because the period is 2 pi. So we're going to regraph the regular sign graph. I'll do that in green. 1, 2, negative 1, negative 2. So we would start at the origin and be there, negative 1, and finish at pi. So we're going to shift all of these to the right, pi over 2. because it's minus. So now we're going to be here. So everything shifted to the right. And there's my graph. So again, minus means you're going to go right. Plus would mean we're going to go left. So if we look at this example, this means we're going to go left power to 2. But we also have that stretch. So we go 1, 2, -1, -2. It's negative power 2, power 2, pi, 3 power 2, and pi, 2 pi rather. So again, a regular sine graph, I'll draw that rather quickly. That's my slide. And therein lies my regular sine graph. We're going to have a stretch, so not impacted, but I move everything to the left. So if I stretched it, I'd be here. I'd be still starting at the origin rather. And then I'd be here, back at the origin, be at -2, and then be back at the x-axis. Now we need to move everything to the left. So for my finished graph, I'm going to be here, everything to the left. That's what my graph will look like. What we have talked about. If you have a graph, or an equation rather, in the form of A sine B times X minus C plus D. A, that's telling you stress or compression. And it's always positive. Always in a good mood. Okay? If you see a negative in front, then that's telling you the reflection across the x-axis. You'll see direction change if you see the negative. And that's what that means. Okay? B is used to find the period. 2 pi over B. C, that's your phase shift. That's going to be left to right. Left would be minus. No, I'm sorry, it's plus. Going left, it's minus. Going right. And D is your vertical shift. So you see plus going up, minus going down. Alright. When looking at these, they need to be in factored form. And we'll go through this chart when you get to your nuts in class. But if you need to watch the videos again, please do so, and we'll get more practice in class. And again, for the filled-in version, check Google Classroom and/or Blackboard for the completed filled-in version.